Okay, now let's start with the questions. So in the first question, there is a person who looks at different trees in an open space with following details. Now we need to arrange the trees in decreasing order of their apparent sizes. So let's try to draw the situation. Let's say this is the tree, this is our surface. Let's say this is the height of the tree, like this. And you're observing from here, so angle here is theta. So this is the distance, this is the height. Let's say this is A and B. Now what is the visual angle made by the tree with the eyes? So it can be calculated by tan theta equal to perpendicular upon base, which will give us AB over OB. Let's say this is OB, this is O. So according to the question, in the we have different situations. So in the first situation, in the second situation, in the third situation, in the fourth situation, let's try to find the angle made by the tree. Now one important thing, this tan theta can be equated to theta if theta is small, then tan theta can be approximated as theta, which will give us theta equal to AB over OB. So height over distance. So in the first one it is 2 over 50, in the second one it is 2.5 over 80, in the third one it is 1.8 over 70, in the fourth one it is 2.8 over 100. So after solving all this, the value of this angles, first 0.04, 0.03125, 0.02571, 0.028. So it is quite clear here that theta A is greater than theta B, which is greater than theta C, which is greater than theta D. Actually it is theta D here and theta C here. So this is the sequence of the angle. So more the angle, more will be the size. More the angle, more is the size. Now an object is to be seen through a simple microscope of focal length 12 cm. Where should the object be placed so as to produce maximum angular magnification? So this is the second one. So let's say that we have a simple microscope having only one lens, okay, convex lens, biconvex lens. Now let's say that the situation is something like this. Let's say this is the object, the rays pass like this, and they appear to meet approximately here. So let's say this is B dash, A dash, B dash, and this is AB. And it is said that the image is obtained at the least distance of distinct vision. So now here F is 12 centimeter, and for convex lens focal length is positive. Now for the distance of the image, it is given least distance of distinct vision. So D is 25 centimeter. So image distance is V, which is minus 25 centimeter because it is on the left side. So by the lens formula, remember in lens formula there is minus, okay, in the formula. From here 1 by u will be equal to 1 by v minus 1 by f. Now let's put the values. 1 upon minus 25 minus 1 over 12. So after solving this, we will get 1 over u equal to minus 37 over 300. So which will give us u equal to minus 8.1 centimeter. So the object distance is 8.1 centimeter, and minus indicates that it is on the left side. Now in the third question, a simple microscope is there, magnifying power is given. Now this magnifying power is when the image is formed at near point, that is at least distance of distinct vision 25 centimeter. Now what is the focal length and what will be the magnifying power if image is at infinity? So this is quite straightforward. We know that there are two situations. In first case, when the image is obtained at least distance of distinct vision, and the another situation comes when the image is obtained at infinity, which is always also called as normal adjustment. So let's ignore that for now. So we know that for simple microscope we have both the formulas. When least distance of distinct vision image is obtained there, then magnification is 1 plus d over f, and when image is obtained at infinity, magnification is d over f only. So now this will be useful for the solution. So let's start with the first part of the question. So what do we have, by the way, in this question? In this question we have magnification, which is 3 when the image is at 25 centimeter, which means that m equal to 1 plus d by f. So by this formula we will be able to find the value of f. 3 equal to 1 plus 25 over f. So from here f will be 25 over 2, which will give us 12.5 centimeters. So this is the first part. Now in the second part, the distance will be infinity. Image is at infinity. So now what can we do? The formula for magnification in this case will be d over f. D is fixed, d is always 25. F is same because the length is same in both the cases. So from this formula the magnification will be 2. So when the image is obtained at infinity, it will be twice the size of the object. Magnification is 2 times. In the fourth question we have a child who has who has a near point at 10 centimeter. What is the maximum angular magnification the child can have with a convex lens of focal length 10 centimeter? So the fourth one. So what do we have? We have d equal to 25 centimeter because it is d equal to 10 centimeter because it is given. Then f is equal to 10 centimeter. So maximum angular magnification m is obtained by this formula. Okay, this case because it is closest, so it will be 2. In the fifth question we have simple microscope which is rated 5x or 5 times the magnification for a normal relaxed eye. What will be the magnifying power for a relaxed far-sighted eye whose near point is 40 centimeter? So this is fifth one. So relaxed eye means that it is normal adjustment, that is the image is at infinity. So in this case we know that for when image is at infinity, the magnification is obtained by this formula d by f. So m is 5, that is given, d is 25, it is fixed, so we can find f easily, which will be 5 centimeters. Now for relaxed eye, in the second situation that they have given, d is equal to 40 centimeter. So then in that case it will be 40 over 5, so magnification will be 8. So here the magnification will come out to be 8x or 8 times. In the sixth one, we need to find the maximum magnifying power of a compound microscope having a 25 diopter lens as the objective, a 5 diopter lens as the eyepiece, and the separation 30 cm between the two lenses. The least distance for clear vision is 25 cm. So this is the sixth one. Now let's try to draw the situation. So let's say we in a compound microscope we have two convex lenses. Object's focal length is less and eyepiece focal length is more. Let's say that this is our object AB. Now let's say that after the refraction of light, the image is obtained approximately somewhere here. So this, let's say this is A dash, B dash. Now this image will be the object for second lens or eyepiece lens. So the image by this lens will be obtained somewhere here, as this will go like this and this will go like this approximately. So it will be like this and they will meet over here and the image will be obtained here, which will be called B double dash, A double dash. Now this is given that the final image is obtained at least distance of distinct vision, so it will be 25 cm away from the eyepiece lens, because from the eyepiece we are observing, and it is given that the distance between the lenses is 30 cm. So this is the situation that we have. Now what are the other things given? Objective lens focal length is 0.04 meter. How? Because we know that f is 1 over power, so its power is given 1 over 25, which will give us 0.04 meters. Now similarly the eyepiece lens will have focal length 0.2 meters by this formula. Power of eyepiece 1 over 1 over 5, which will give us 0.2 meters. Now let's do for the situation that we have. So d equal to 25 centimeter is the separation between objective and the eyepiece. It is 30 centimeter, and now let's try to find the magnification. So this is our final lens. Okay, so this is our final image, this is the object. So distance between the image is 25 centimeter. So VE minus 25 centimeter, and the FE is given as 20 centimeter. So from here, by the lens formula, we can find the final location of the image. We have that, but we can find the location of the object for which we can have this image. So from here UE will be equal to 11.11 centimeters. So ultimately the object will be situated at, or the image for the object lens will be at 30 minus 11.11, which will give us 18.89 centimeter from the lens. Now for objective lens, this was for eyepiece lens. SVO is 18.89 centimeter, F naught is 4 centimeter. We can find the initial position of the object by the mirror formula. After putting the values, we will obtain minus 0.197, or u will be equal to minus 5.07 centimeters. So it is a long question which has to be done in steps. Now let's try to find the maximum magnification. So the maximum magnification in case of compound microscope is given by this formula. So here 18.89 over 5.07, 1 plus 25 over 20. So after simplification we will obtain magnification to be 8.376. So this is the final or total magnification. Now in the seventh question, there is a separation between objective and eyepiece which is given. Now if the focal length of objective and eyepiece are 1 and 6, we need to find the range of magnifying power if the image is always needed at 25 cm from the eye. So in the seventh question we have a few things. First of all, object lens has this much focal length, eyepiece has this much focal length, and the final image will be always obtained 24 centimeter away, so it will be 24 centimeters. Now for the eyepiece we have VE equal to minus 24 centimeter and FE is equal to 6 centimeter, because this is the final image by the eyepiece lens. So from here we can find the location of the object for the eyepiece lens, just like we did in the above question. So UE will be, let's put all the values. 1 over UE will be equal to 1 over V minus 1 over FE. So 1 over UE equal to minus 1 over 24 plus 1 over 6. We have taken minus outside. So ultimately what we will have? We will have 5 minus 5 over 24. So UE will come out to be minus 4.8 centimeters. Now the first situation. So in the first situation the separation between objective and eyepiece is 9.8. Now image of distance of the object lens must be, so what will be the image? Let's say this is our diagram. Let's say this is the principal axis, this is object lens, this is eyepiece lens. So what do we have? We have separation equal to 9.8 centimeters. Now we know that the situation is like this. So the image distance from the object lens will be 5 centimeter. This is at 4.8 centimeter from eyepiece. So this point will be 5 centimeter from the objective. So that is what we have, that VO will be 5 centimeters. The image obtained by the object lens is at 5 centimeter from the lens. So now 1 over UO equal to 1 over VO minus 1 over FO equal to 1 over 5 minus 1 over 1 equal to minus 4 over 5. So UO will be equal to minus 5 over 4, which will give us minus 1.25 centimeters. Now let's move on to the magnification. So the magnification is given by V0 over U0 1 plus D over F. So minus 5 minus 1. Minus 5 minus 1.25, 1 plus 24 over 6, which will give us magnification equal to 20. So this is the final magnification. Now the B part. Now the situation is a bit different. Here the distances are different. The separation becomes 11.8 centimeter, the image is obtained here, which is 4.8 centimeter away from the eyepiece lens. So the image distance from the object lens will be 7 centimeter. This is the image for objective, and this is object for eyepiece lens. So ultimately now the final image is obtained at where? So what we have V0, that is this distance will be 7 centimeter. Apart from that, we have FO equal to 1 centimeter. So UO can be found out, the initial position of the object, actual object's position. So this will give us UO to be equal to minus 7 over 6. Now magnification, minus VO over UO, 1 plus D over F equal to minus 7 over minus 7 by 6, 1 plus 24 over 6. So magnification will be 6 into 5, 30. So 30 times magnification. In the 8th question, an eye can distinguish between 2 points of an object if they are separated by more than 0.22 mm. Now when the object is placed at 25 centimeter from the eye, okay, this is a situation. Now if the object is now seen by compound microscope having a diameter having 20D objective and 10D power of eyepiece separated by distance 20 centimeter. The final image is obtained at 25 centimeter from the eye. We need to find the minimum separation between the 2 points of the object which can be now distinguished. So this is the 8th one. So now let us try to understand the situation what we have. Object lens focal length can be found at 1 over power, which will be 0.05 meters or 5 centimeter. Eyepiece lens power will be 1 over 10 diopter, 0.1 mm or 10 centimeters. D is 25 centimeter of here. Next is separation between lenses is 20 centimeter. Now for eyepiece V is minus 25, V is minus 25 centimeter, FE is 10 centimeter. So from here UE can be obtained 1 over minus 25 minus 1 over 10. After solving this, UE will come out to be minus 50 over 7 centimeters. Now this will be the image for the object lens. So for object lens VO is 20 minus 50 by 7, that is 90 over 7 centimeter. What does this mean? This means it is 50 over 7 centimeter. So we need to find this distance, and this distance is, let's say, 20. So this distance is 20 minus 50 over 7. So V0 is now known. So by the formula we can find the original location of the object. So U0 equal to minus 90 over 11 centimeter. Now maximum magnifying power is M equal to minus V0 over this formula, that is we are using for quite a lot of questions now. 90 over 7, 90 over 11 1 plus 25 over 10. After solving this, you will get that magnification will be 5.5 times. So minimum separation I can now distinguish will be equal to 0.22 over 5.5 mm. So it will be equal to, it will come out to be 0.04 mm. So what is this? What is the minimum separation? So it is equal to original resolution over the magnification. Original resolution over the magnification. A compound microscope has a magnifying power of 100 when the image is formed at infinity. Now objective has a focal length of 0.5 cm, tube length is 6.5 cm. We need to find the focal length of the eyepiece. So this is the 9th one. In the 9th one, what do we have? FO is 0.5 cm, tube length is 6.5 cm, magnifying power is 100 for normal adjustment, that is when the image is obtained at infinity. Now what do we have? So the situation is something like this. This is our convex lens, this is another convex lens. Now let's say this is our focus of the eyepiece. So this is the focal length and the image is obtained at the focus of the eyepiece. So this is the image distance for the objective lens, V0. Ultimately, after all the simplification, image will be obtained at infinity for normal adjustment. So it is clear from here that V0 plus Fe, it is given that the distance between the lenses is 6.5 cm. So V0 plus Fe will be 6.5 cm. Now for normal adjustment, the formula for magnification is V0 over U0 into D over F for normal adjustment, that is image obtained at infinity. So magnification will be minus, if we simplify it further, we will obtain 1 minus V0 over F0. D is 25 over eyepiece Fe. Why? Because V over U0 is equal to 1 plus V0 over 1 minus V0 over F0. So 100 equal to minus 1 minus V0 over 0.5, 25 over Fe, 100 Fe equal to minus 1 minus 2V0 into 25, 2V0 minus 4Fe equal to 1. This is our second equation and this is our first equation. So by equation 1 and 2 we will get V0 equal to 4.5 cm and Fe equal to 2 cm. So the focal length of eyepiece lens is 2 cm.